Right now, something ancient is tearing through our solar system at a speed that defies comprehension. 58 kilometers per second. That's over 130,000 miles per hour. Fast enough to cross the United States in less than a minute. But speed isn't what makes this visitor extraordinary. It's where it came from, how it arrived, and what it's made of that has astronomers questioning everything they thought they knew about the cosmos beyond our borders. This is the story of 3I Atlas, the comet that shouldn't exist. August 2024. Telescopes across the globe begin tracking an anomaly. Not a star, not an asteroid, something else entirely. Within weeks, the calculations are undeniable. This object isn't bound by our sun's gravity. It's passing through, a traveler from the deep void between stars. We've had visitors before. Oumuamua in 2017, that strange, elongated enigma that sparked 1,000 theories. Borisov in 2019, our first confirmed interstellar comet, behaving exactly as comets should. But 3I Atlas? Atlas is different. Most interstellar objects plunge into our solar system from steep angles, diving down from above or below like meteors cutting through atmosphere. They respect no plane, no order. They come from the chaos of three-dimensional space. Atlas didn't do that. It entered on what astronomers call a T-bone trajectory, sliding in almost perfectly aligned with our solar system's ecliptic plane, the flat disk where planets orbit. Imagine a cosmic highway, and Atlas merged onto it like it knew exactly where the entrance ramp was. This isn't just unusual, it's geometrically improbable. And it's our first clue that this visitor carries secrets from a region of space we're only beginning to understand. Where do you come from when you travel between stars? The answer lies not in our neighborhood, but in the ancient architecture of the Milky Way itself. Our galaxy isn't uniform, it's layered. The thin disk, where our sun lives, is young, relatively speaking. Bright stars, active star formation, the bustling metropolis of the galaxy. But below it, there's something older. The thick disk. Formed over 10 billion years ago, the thick disk is a relic from our galaxy's violent youth. Stars there move differently, faster, more erratically. Their orbits are tilted, chaotic, remnants of ancient collisions and mergers that shaped the Milky Way's early existence. And the objects that orbit those stars? They've been wandering the darkness for eons. Based on its trajectory, its velocity, its composition, astronomers believe 3I Atlas was born there. In that primordial realm, a frozen archive from the galaxy's distant past, now hurtling through our present. Think about that. This comet is older than most stars we can see with the naked eye. It's traveled distances we can barely conceptualize. And somehow, against all odds, its path intersected with ours. Size matters in space, and Atlas is colossal. 5.6 kilometers wide. That's over 3 miles of ancient ice, rock, and mystery. To put that in perspective, the asteroid that ended the age of dinosaurs was roughly 10 kilometers across. Atlas is more than half that size, but size is only part of the story. What this comet is made of, that's where things get truly strange. Most comets in our solar system are dirty snowballs, water ice mixed with dust and organic compounds. When they approach the sun, that water ice heats up, turns to vapor, and creates the glowing coma and tail we associate with these celestial wanderers. Atlas doesn't work that way. Spectroscopic analysis reveals something unexpected. This comet is composed primarily of carbon dioxide ice, not water. CO2, the same gas we exhale. The same substance that makes dry ice smoke and vanish at room temperature. And CO2 ice behaves very differently than water ice. It doesn't need as much heat to sublimate, to transform directly from solid to gas without becoming liquid first. Which means Atlas started its spectacular transformation far earlier than any native comet would. While still as distant as Jupiter's orbit, billions of miles from the Sun's intense heat, Atlas began to awaken. Gas erupted from its surface. A massive coma, a temporary atmosphere, bloomed around it, growing to dwarf even the largest planets. Then came the phenomenon that made headlines worldwide. Atlas grew a tail, but not the kind you'd expect. Comet tails always point away from the Sun, pushed by solar wind and radiation pressure like cosmic windsocks. It's one of the most reliable patterns in astronomy, except when it isn't. In its early stages, far from the Sun, Atlas displayed something rare, an antitail, a projection that appeared to point toward the Sun, defying the usual rules. But this wasn't magic. It was geometry. As the massive sublimation began, particles were ejected in all directions. From our perspective on Earth, looking at a specific angle, some of those particles created an optical illusion. They appeared to be moving sunward when they were actually just spreading out along Atlas's orbit. It's like looking at a highway at dusk. The headlights coming toward you seem brighter, more focused, even though cars are traveling in both directions. Perspective creates reality. Still, for a brief cosmic moment, Atlas seemed to be breaking the rules, and astronomers scrambled to document this fleeting display before it vanished into the glare. March 2025. Atlas makes its closest approach to Mars. And waiting there, on the rusty surface of the red planet, is humanity's most advanced rover, Perseverance. From its vantage point in Jezero crater, Perseverance turns its cameras skyward. The images it captures are unprecedented. An interstellar visitor photographed from the surface of another world. In those images, you can see the coma, the developing tail structure, the glow of sublimating gases catching sunlight. But more than that, you can feel the significance. Here's a comet from beyond our solar system, passing by a planet where robots built by humans are actively searching for signs of ancient life. Two explorers, one mechanical, one primordial, sharing a brief moment in the vastness. The data from this encounter is still being analyzed. Comparing how Atlas appeared from Mars versus how it appears from Earth gives astronomers crucial information about its true shape, rotation, and activity patterns. But the window is brief, because Atlas has an appointment with the Sun. Every comet's journey has a climax, perihelion, the point of closest approach to the Sun. For Atlas, that moment arrives in late 2025 and early 2026. The comet swings through the inner solar system, its CO2 ice sublimating furiously now, its tail streaming behind it for millions of miles. But there's a problem. From Earth's perspective, Atlas is now positioned almost directly behind the Sun. Lost in the glare, unobservable. It's the astronomical equivalent of losing sight of a ship as it passes behind a lighthouse beam. You know it's there. You can calculate where it should be, but you can't see it. This is the danger of having only one observation point. We've sent probes to distant planets, but we don't have spacecraft positioned to observe the Sun from multiple angles simultaneously. So we wait, checking coordinates, running simulations, hoping that when Atlas emerges from the Sun's glare, it's still intact, still active, still giving us data. March 2026, the next chapter. Atlas, having survived its close encounter with solar radiation, is now speeding outward, and directly in its path is the giant of our solar system, Jupiter. This isn't a collision course. Atlas will pass safely by the gas giant. But safely is relative in space. It will come close enough for Jupiter's immense gravity to interact with the comet's trajectory. astronomers are preparing. Every major telescope that can train its lens on Jupiter will be watching. Space-based observatories will capture data across multiple wavelengths. Even amateur astronomers with backyard telescopes might catch a glimpse. This is our last chance. Because after Jupiter, Atlas will be accelerating toward the outer reaches of our solar system. Within months, it will cross Neptune's orbit. Within years, it will pass beyond the Kuiper Belt, beyond the heliopause, beyond any reasonable definition of our space, and then it will return to the darkness between stars. Forever. In the grand cosmic timeline, Atlas's visit to our solar system is a heartbeat, a blink. It spent billions of years crossing the void, weeks in our neighborhood, and now it will spend billions more traveling to… where? We don't know. We can't know. But for this brief moment, we shared space with something ancient, something that has witnessed corners of the galaxy we may never reach, something that carries, frozen in its core, a chemical record of star systems, long dead. We are watchers on a small blue world, looking up at infinity, and sometimes infinity looks back. Atlas reminds us that our solar system isn't isolated. We live in a galaxy filled with billions of solar systems, and between them, objects drift in the darkness, refugees from gravitational battles, exiles from dying stars, time capsules from the universe's deep history. This won't be the last interstellar visitor, but it might be decades before we see another like Atlas, arriving from the ancient thick disk made of alien ice, traveling on an impossible trajectory. So we watch, we calculate, we wonder, and when Atlas finally fades from our instruments, disappearing back into the cosmic night, we'll remember what it taught us, that the universe is stranger, older, and more connected than we ever imagined. The comet that broke all the rules has left the building, but it won't be forgotten.